So today I'm playing in my shop, and finding new, old things that I'd, been missing. Found this and cleaned it up a little bit. I'm not like worried about its antique value. I know it's real old. So I cleaned it up. Um, and what I did was I use a handheld zooper that goes round and round and round. Okay. Now, if I were to like zoop on my wrench here, that is, tool steel, right? It's a mixture of iron and nickel to make a very hard steel. And I love tools, man. I just love tools. Ace Hardware makes some really great tools. These are about as close to a snap-on as you can get. They look like a snap-on, feel like a snap-on, act like a snap-on. It doesn't, twist off your 10 millimeter nuts and bolts, which are a common thing, 10 millimeter, right? Um, and then there's this. And the less nickel there is in it, this one's real soft and would twist out right away, right? Um, and this end, pretty good. But this end, if you start wrenching on it, it's going to spread because the nickel makes the stuff harder. Okay. Now, if I start zooping on this one, or this one, or this one, in about 3 seconds, maybe 30, 15 seconds, something like that. I don't know. I don't actually do it very much. Um, it gets too hot to hold almost right away. There's no, it starts resisting the heat and storing the heat right around where you're working, but it also transfers it through the metal. Transfers it fairly quickly, but not very quickly. Okay? This one I held in my hand and I zooped it for about a half an hour. And where I was, when I zoop like here, I can then, put my finger on it and touch it. Because this has no resistance to the heat. The heat transfers from that point through the rest of the metal and it just cools it down, right? It's like a big radiator. You can zoop here and it's radiating the heat away. When you solder on platinum, on AUPD, like this stuff, or it's not soldered. I don't know how they did it, man. Because this is real old. It's not like they could arc weld it. I mean, I don't think so anyway. Maybe they did. But they welded it. They had natural gas. The Chinese did, or Tibetans, along the Yellow River, southern China, starts up in Tibet. And they had natural gas thousands of years ago, like 3,000 years ago, that we know of. And they could weld with it too. They knew what it was for. They were shipping it in bamboo from the wells to the places where they used it. They fired porcelain with it. And porcelain comes from kaolinite clay. They made plates from the stuff I make platinum from. Plates from platinum. And this is AUPT, this stuff. It's got a little gold in it. and mostly platinum. And because of that combination, they line up. Gold has one more electron proton pairs, proton electron pairs, depending on which way you want to look at it, um, than platinum does. And so they line up magnetically. But they're going every which way, right? Because of the cubic structure in there. And so they don't all line up like iron does. Iron is mostly just Fe2 and Fe3. It's got 2 electrons or 3 electrons. That's not an isotope. That is an oxidation state. That's what we call that. Because that iron will then bind with oxygen with either 1, 2, or 3 electrons. So that's what happens. Platinum has either 1 electron in its oxidation state or 4. And gold can too. So does palladium. They're similar metals. Nickel is part of the tool steel, and it is a platinum group metal. So I was mixing palladium stuff that I had in my crucible with my screwdriver, and if you try to solder aluminum to a piece of steel, it doesn't actually work. But palladium binds with the nickel in the steel, I think, and this stuff is welded on there, man. It is not coming off. Isn't that funny? Okay, so as I still use it for mixing stuff in my crucibles. And now it's got this stuff on there, and it wicks away the heat because it's a superconductor for heat and magnetism. Iron will resist magnetism. That's why it sticks to it. Palladium doesn't stick to it, neither does platinum. They're diamagnetic because of that gold platinum or gold palladium structure. But it is diamagnetic because they're going every which way. They don't all line up in the same directions. You can see which directions they're lining up here by the little stringy looking things. And those are planes of cleavage along the cubic structure of the crystal. You can see it, woo, in the end there. Yeah, cool looking, man. I mean, I think it's kind of cool looking. So anyway, that's I love tools, man. And I love this stuff because we can replace steel and aluminum with this stuff. This stuff comes from the dust on the side of the road, from volcanic ash that covers the earth in layers hundreds of meters deep, covers the entire planet, right? The stuff they have in China, it's the same stuff I've got over here in my backyard. We just live on a little tiny planet. And this stuff is literally everywhere. And I recover this stuff with zero ecological damage And I was using electricity to melt this. I wasn't using like oxyacetylene or something like that. So zero carbon footprint. And I make electricity with wind power, solar power, water power, or steam power from hydrogen, oxygen, gas. We can make these metals and they can replace steel and aluminum, and both of which are just ecological disasters. The mining of it, the processing of it. And, I don't want to put people out of work either, man. I want to go back to the stars. This is not to make us go back and live in the woods. It's the other way around, man. This is what you make spaceships out of. Peace, y'all.